Hi everyone, it's Orkan. Welcome to my channel. Today we are going to solve LeetCode 1143 longest common subsequence problem. So let's first take a look at the problem. The problem is that we are giving two strings, text1 and the text2, and we need to return the length of their longest common subsequence. If there is no common subsequence, then we are returning 0. And we are given a clarification what the subsequence is. Subsequence is of a string is a new string generated from the original string with some character, can be non-deleted without changing the relative order of the remaining characters. So what's that mean? For example, in this case, ACE is the subsequence of ABCDE because we are removing from here B and D, so we are having ACE, which is the subsequence of ABCD. And we are given a definition of the common subsequence, which is the two strings in a subsequence that is common in both strings. So for example, in this case, in ABCD E and the ACE, the common subsequence is equals to 3 because ABCD contains ACE. In another example, we are given ABC and ABC, so they are equal. We are just returning 3. And in this case, ABC and DEF, so there is no common subsequence. In that case, we are returning 0. All right, that's it. That's the problem statement. Let's see which approach we are going to use in order to tackle this problem. Okay, let's take actually our example A, B, C, D, E, and A, C, E, and work on it. So in this case, our common subsequence is equals to 3 because we can delete B and the D here, and we can get to this A, B, C, E. So how we can solve this problem? The way we are going to solve this problem, we can so we are going to use dynamic programming, and more specifically bottom-up approach. So what we are going to do, we are in general in dynamic programming, we are taking a problem, we are chunking that to sub-problem, and we are solving that sub-problem, and then we are building up our solution to our problem. So what's that mean? So first we are going to take A and A, and we are going to check, okay, we are going to solve only this subproblem, A and A. Then we are going to solve another subproblem, A, B, and A. So since we solve that problem, once we are expanding our strings to the larger strings, so we can use the solutions that we have. We can use the solutions that we have, subproblems that we have already solved. So we don't have to solve them again. So I think let's go and put that into two-dimensional array. That would be more clear. So let's say that in this case we have 0, 1, 2, 3, 4, 5, right? We have A, B, C, D, and E. And in this case, we also have 0, 1, 2, and 3. We have A, C, and E. So let's create two-dimensional array. Okay, so and build up our solution. So all right, this one. Yeah, so we can populate here with the zeros. So because there is no value at this point. So let's just take the one case, right? Let's say that we have only A and A. We are solving only this subproblem. Is A equals to A? Yes, it equals to A. So it means that the common subsequence in this case is the size of it is equals to 1, right? So it equals to 1. And then let's move to the next one. How about the A, B, and A? So b is not equal to a, so we are just populating everything here as 1, right? So now let's go to the second one. Second one, we have c here. C is c equals to a? No, it does not. So we are taking the value. So we have already solved this subproblem, right? So now we are solving the solving the subproblem that the AC and A. So we solved subproblem A and A. Now we are solving AC and AC and A. So for this subproblem, it's not equal. So we are taking the maximum of AC and 0, which is equals to 0, or we are taking from the left, or we are taking from the top, or A and A, which is equals to 1. So we are adding here, it equals to 1 in this case. So next, we are going to the next element. It's the same. We are taking either from the left or from the top. So either AB and so AB, AC. So now we are solving AC and AB, right? So AB and the AC. So for AB and AC, it's either AC and A or AB and A. So whichever is the maximum one. So either from the top or from the left. So both of them are 1, so it equals to 1. Now let's go to the next one. Next one is that we are checking, is C equals to C? Yes, it equals to C. So it means that 1, but we need to take another subproblem that we already solved. So the subproblem that we are solving right now is AC and ABC, right? ABC. So the subproblem, so what is the, so we see that the C is equals to C, and what we need to do, we need to take the value that we have already solved. So we need to take the value AB, right? So C is equals to C. We need to take the value of the AB, so let me put that in another color. We need to take the value of A and AB, right? So which means that A, AB, and A, which means from, AB and A, which means that from here. So this value, 1 plus 1 is equals, now it will be equal to 2. So then we are again going to the next one, D, taking either from the left or from the top. So either from the ABCD A, or from the left AC and the ABC. So whichever is the maximum. Maximum here is 2. So we are populating it as a 2, and the same for the E, we are populating as 2. Now let's go to the last one. The last one is that E. So the last one is the E. So E is not equals to A. So we are taking either from the left or from the top. So that's, and the value is 1. So we are adding here 1. The same, we are B is not equal to E, either from the left or from the top. We are adding 1. We are adding 1. So then we are going to the next one. E is not equal to C. So we are taking either from top or from the left. Then the value is maximum is 2. The next one is that the E is not equal to D. We are taking either from so in this scenario, right? Just one more time to reiterate on that. So the subproblem that we are solving at this specific point is ABCD and ACE. ABCD and ACE. ACE. So what's that mean? It means that D is not equal to E. D is not equal to E. So we can either take that the maximum, whatever is the maximum, A, B, A, C, so whatever is the maximum, A, C, E, A, C, E, A, B, C, A, B, C, this one, or reverse, right? We can take that A, B, C, D, and A, C, which means that this one. So two combination, whatever is the maximum. So that's why we are taking from the left and from the top. So the maximum is both are equals to 2, so we are adding 2. Now we are taking the last one, which is ABCD and ACE, right? Let's take that in another color also. So we are taking ABCDE and we are taking ACE. So the last one, ABCDE and ACE, right? So we know that this E is equals to E, so it's a +1 already. So then what we need to do, we need to take the maximum of the ABCD. So whatever the value is that for ABCD and AC. So for ABCD and AC, the value is ABCD and AC, the maximum is, we already solved that, and it equals to 2. So we are adding 2 here, and our total value is equals to 3. Okay, I hope it's clear. So again, that the point of it is that we have a problem, and we know that, okay, we can break down that problem to sub-problem, so we can solve that sub-problem, and then we can build up our sub-problem to our solution. For example, in this case, right, we are just taking A and A. Then we are taking A and AB, A and AC, and A and AD, and so on. And we are populating values in our two-dimensional array. So once we arrive to this point, so it means that we have already solved all those sub-problems. We can use those sub-problems in order to solve the bigger problem that we have. And as you can see here, the algorithm is that if they are not equal, we are taking either from the left or from the top, and we have seen here why. Or if they are equal, we are taking from here because that they are equal, right? E is equal to E, and we need to take the value of ABCD and AC, which is equals to 2. Okay, I hope that's clear. Let's go to the solution part. Right, let's start. First thing that we are going to do, we are going to take the length of our string. So let's take the text 1 length, and the same way we can take the second one. Let's just call it S2 and text 2, because we are going to use them extensively. So next thing we are going to do, we are going to create a two-dimensional array. Let's just call it DP, which stands for dynamic programming. And let's create an array of int with the size of f +1, first +1, and the second +1. So zeros here we are going to populate with the zeros is going to be populated with the zeros by default. So let's go over and start with the I is equals to 1 because zeros are equals to zeros. We are just mimicking whatever we have put in our solution part, in our step-by-step explanation part. I is equals to 1. I is less than f is equals to less than or equals to f length, so just f in our case, and I ++, and then we can just copy paste this, j and j and j. So what we do here, so we are going, now we are populating our two-dimensional array. So what we do, we are comparing if text 1 character at I minus 1 equals to, let's copy paste this, equals to text2 character at j minus 1, so which means that the characters at that point, if they are equal, then what we do, in this case, we are adding, they are equal, so which means that the dp I and j equals to 1, as we said, like for example, if the characters are equal, so we already have 1, plus we are adding whatever is that the subproblem that we solved earlier. The subproblem that we solved earlier is the same, dp I minus 1 plus j minus 1, okay, j minus 1. Else, if they are not equal, in that case, what we are going to do, we are going to take the whatever is the maximum, so either from the up or from the left, right? So we are going to set to the dp I j, we are going to set math maximum, that is the maximum dp I minus 1 j and or dp I j minus 1, so either from the up or from the left, right? J minus 1, and that's it. So after we exit this loop, we populated our dp with the all populated with all values that we need. We solved all the subproblems. Now we build it up. Now we are returning the solution for our problem. So which is dp first and the second. Okay, let's see that how. Right. Character at, let me see. Character at I minus 1. Text 1. Okay, text 1. Text 1, yeah. Okay, second should be here. Okay, great. It works as expected. So let's go over it one more time. So which approach we are using in this case? We are using dynamic programming, and specifically bottom-up approach. So we are creating a two-dimensional array with the size of m to n, or first and second input strings. So we are populating first zeros with the zeros, and then we are building up our solution. So we are taking subproblems one by one, and we are checking that if the character is if they are equal, so which means that we have at least one, so right, plus whatever subproblem we have solved earlier. The subproblem we have solved earlier is that the one, so for example, let's say that they met at the point when the first one is equals to, size of the first one is equals to 4, and the size of the second one is equals to 5. So we are taking first, then we are taking maximum of the when the size was 4 and the size was 3. So that's why we put here dp I minus 1 and the j minus 1. So 1 plus whatever the subproblem that we have solved earlier. If they are not equal, then it means that we are taking that whatever is let's say that again the size is 5 and 4, right? Whatever is that the 5 and 3 or 4 and the 4. So whatever is the maximum, so either from the left or from the top, we are taking that and we are populating our two-dimensional array. And at the end, we are returning whatever. So we are building up our solution from, we are solve the subproblem, then we are build up to our solution, and at the end we are just returning value, whatever we set for the first and the second. That's it. That's it for today. Hope you like it. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.